Right, this is the CAPS DBE Nsc Mathematics Paper 2 from November 2022. Going to be looking at question 4, an analytical geometry question. Question 4, it's given, this diagram is given. M is written on the diagram as the midpoint, the center of the circle, and N is given, which is a tangent to the circle. Having Pn as the diameter, so this is the diameter, and KL, KL is the tangent, okay, tangent to that circle. Question 4.1, calculate the coordinates of P. So we want the coordinates of P. Here's just a simple midpoint formula question, but the unknown is the P. So we know we can say the midpoint of Pn. We have the midpoint formula is the x's added together, and the distance between them divided by 2, and then the y's added together divided by 2. So it's literally halfway between the distance of the two. That'll give us a capital M midpoint Pn. Let's sub in our values. And we know P, we don't know, so we can just say x1 plus our 7. 7 comes from point N. And then we have that over 2. And our y1 plus minus 2 all divided by 2. Okay, so this is our midpoint of Pn. But we also know that the midpoint is M. The point M, 3 minus 5, is in fact the midpoint Pn. So it's equal to the midpoint Pn. So this means we can split this up. So we can say that 3 must be equal to the x part, which is x1 plus 7 over 2, because it's the same thing. And also we can say that minus 5, the y part, must be equal to y1 minus 2, plus minus 2 is minus 2 over 2. A quick solving for this, times both sides by 2, 6 equals to x1 plus 7, minus 7 on both sides, 6 minus 7, x is minus 1. Over here, times both sides by 2, we get minus 10 is equal to y1 minus, minus 2. Plus 2 on both sides, plus 2 is y1 is equal to minus 8. So our final answer, point P, is minus 1, minus 8. Question 4.2.2, 4.2.1, excuse me. Write the circle in center radius form. So this is center radius form. Okay, so we have center radius form and our circle with center M, x minus a squared plus y minus b squared equals to r squared. Well, the center radius form, this AB is the opposite signs. And this is the center point of the circle. A and B is the center of the circle with opposite signs to what is here. Whereas this R is the radius of the circle. So we already have the center of the circle. We can just sub it in. It's M3 minus 5. So it's x minus 3, opposite sign, squared, plus y plus 5, opposite sign, equals to r squared. The last step is we need our radius, and our radius is just the distance from the center to N, or it could be from the center to P. that's the radius of the circle is half of the diameter. We could also do the diameter and divide it by 2, but let's do the distance mn. Distance mn, distance formula. Distance formula is x1 minus x2 squared plus y1 minus y2 squared. And remember, if you start on n, you start here, then you need to start on the x, and you're also going to start on minus 2. So order matters because of these negatives, order matters. So it's the square root of x1 would be 7 minus, from going to now, this would be our x, x1, x2, x, y, y1, x1, x2, y2. Okay. So we have 7 minus 3 minus 2 minus 5. Put all this straight, that's squared. Put all this straight into your calculator. And we get that our radius is our 5, which is the radius. And last step, x minus 3 squared plus y plus 5 squared is equal to 5 squared. So in the exam, you probably want to square that. And your final answer should be equal to 25, because 5 times 5, or 5 squared, is 25. Right, that's the end of question 4.2.1. 4.2.2 asks for the tangent KL in the form y equals mx plus c. So m is the gradient, and c is the y-intercept. It's the y part of the y-intercept, the y of y-intercept. So you can first get the gradient, because we know that because KL is a tangent, m times m equals 90 degrees. So the tangent meets the diameter at 90 degrees. So that's here. And we know that because of that, we know that when two lines meet at 90 degrees, then the two gradients are going to equal, not 90 degrees, they're going to equal -1. Okay. So what can we do with this information? Well, we can find the gradient of NP. Gradient of NP. So doing NP is using the gradient formula y2 minus y1 over x2 minus x1. So if we start on y2, then we have to start on x2. Same thing as shown in the distance formula, the gradient formula, order matters. So if we start on n, we have to start on x of the n as well. So -2, we're going to p, minus -8. Those are the two y's, and then we have 7 as our x, minus -1. All right. -2 plus 8 is 6. 7 minus -1 is plus, so 6 over 8, which is 3 over 4. Divide both by 2 to get the simplest form. There was a negative, it was -2. Let's just check. -2. No, it's all good. So it should be a positive gradient. It's facing this way. Okay. So far we've got the gradient of NP, but we know that the gradient of NP times by the gradient of KL. Must be -1. So to put it, this just means we're going to take that 3/4, change the sign, and flip it around. So it'll be 4/3. That is to show the working. The working would be MNP is 3/4 times by MKL is equal to -1. And so when you divide both sides by 3/4, -1 times 4/3, if you tip in times, and -1 times top, bottom times bottom is -4/3. So just to see, and also just use the calculator. Those cancel out. And the gradient of KL is -4/3. We're not quite done. We've got the gradient. So far, we have the gradient of KL. So y is equal to -4/3x plus c. We've got still an unknown c. And for this, we can sub in point N because we know it's on KL. So we can sub it in. Seven -2. So sub in the y, -2 equals to -4/3, 7 plus c. 4/3, -4/3, 7. 7 times 4, 28 divided by 3. Let's just check that on the calculator. 4, 3 times 7. All right, -28/3 plus c, -2. We just simplified that a little bit. So then we plus 28/3 on both sides in order to get, so -2 plus 28/3 is equal to c. Now you can just use the calculator for this, but just for the sake of it. So if we had -2, we'd have to get a common denominator of 3. We times it by 3/3. So we -2 times 3 is -6/3 plus 28/3 equals to c. 28, so it'd be 20. C is 22/3. Okay. 22/3. Well, obviously, in an exam, don't have time for this. You can use your calculator straight away. Final answer, y equals -4/3x plus 22/3. I think that concludes 4.2.2. For 4.3, for which values of k will this be a secant to the circle? Well, I've already see that that's the tangent KL. So we're looking at the tangent KL. And it touches here, a tangent by definition touches the circle once. And it's saying K, which moves the gradient is going to stay the same. So the gradient is going to stay the same, but the line is going to move up and down. So it's going to move sort of along here. Okay, so, or it can move to here. So as you change K, the line will move in that fashion. So we know that a secant is a line that cuts the circle more than once. The secant cuts the circle more than once. So this KL, between where it is at the moment, so where it is at the moment, which is at point N, until it gets to here, where it's a tangent again, all the in-between spaces here, it's a secant. So that's the question is asking what values of K will move the line in that way. Looking at a graph here, it's going to be between the x's of, it's going to be between n and p. So we need what x's bring KL between n and p. So k is currently, from a previous question, 22/3. So where KL, it's just a coincidence that there's two Ks, but where the line KL is currently, then our K value is that. Okay. So because of this, we already know that K has to be, the upper boundary of K is that it has to be less than 22/3. It has to be less because it's going, that'll bring it in that direction. So it has to be less. What we don't know is what will it be at point P? What will our K value be at point P? And to get the lower boundary. So we want to know, well, when will it be a tangent again? Stop being a secant and end up being a tangent again. And the way we can do this is we sub our point P, which we have from a previous question, into KL. So we're saying, where does point P lie on KL? So our new KL. And at that point, if we go further than that, we're no longer secant, we're no longer tangent even, it's just not even touching the circle. It goes further to the left. Okay, so -8 is equal to -4/3 and -1 plus 22/3. What's wrong with this? Something's wrong with this. What are we actually looking for? There's no unknowns. We want K. So no, it's not going to be 22/3 anymore. It's going to be an unknown K value that we're trying to solve for. Okay. -4/3 times -1 is just 4/3. -8. Plus K. Then we -4/3 on both sides. -8 minus 4/3. Again, this cancels out. You can just put that in the calculator, but let's look at the working behind it. So you have to get a common denominator of 3. So you have to times 8 by 3/3. 8 times 3 is 24. So it'll be -24/3 minus 4/3 is equal to K. K is -28/3. -28/3. Right. So this is our lower boundary here at point P. So we know that K also has to be, in order to be a secant, K also has to be larger than -28/3. We put this into this format, so we can just put K must be between -28/3 and the upper boundary of 22/3. Just to note, not equal to, so not equal to, it's just, if it's equal to, it's a tangent. That's the final answer for 4.3. Okay. Number 4.4. A point A, T, T, and B are not shown on the diagram. From point A, another tangent is drawn and it touches the circle with center M at B. So basically, if we had a point, it's going to touch at point B and it's going to be a tangent line here. Okay. So, I mean, this B can be anywhere on the circle. They haven't given any other information. Then it says, show that the length of the tangent AB is given this way. Point A, T, T. So where is our point A? Point A is not shown on the diagram. from point A. So point A, I'm going to put my point A over here. Point A could be anywhere on this tangent line. That's A, T, T. So that point could be anywhere on the tangent line, but that's where I'm going to put it. And the question asks, what is the length? So anytime we have a length of tangent AB, whenever we have the length, we're going to be using the distance formula. So the question is asking for the distance of AB. The distance AB equals what? This is question 4.4.1, and they've given you that it's going to be the square root of 2r squared plus 4r plus 9. So this is already gives a little bit of clues that they're using r, which is the radius, and that it's got a square root, which to me, whenever I see a square root, it's either because it's a distance formula or because of Pythagoras. Those are the two reasons that distance formulas have square roots in them, and Pythag has squares. Which means that if you want to isolate one of them, you're going to have to do, for example, c squared would be the square root of a squared plus b squared. So those are the two times, if any time that I see a square root, I think either radius or Pythag. Pythag. I'm looking at this pink line that I've drawn in for myself, and I realized that since it's a distance that we're looking for, we don't know what A is. So we're gonna still have, we need this in terms of the radius. So it's a little, currently I still can't work out what A is using just the distance formula. So I want to look at the other information that was given us, and we were given that B is a tangent, which means that B hits the circle at a 90 degrees angle. And if we make a Pythagorean triangle, just going off, as I said, the square root thing, it might be Pythagoras. So I'm just looking at it. If we make a 90 degrees triangle here, well, we can easily get what BM is, the distance BM, and we know what distance BM is. It's 5 because it's the radius. We could easily get that's the only information I can see there so far. Let's start writing down what we have. Well, we know that AB squared must be equal to AM squared, which is the hypotenuse of the Pythagorean triangle, minus BM squared. The reason is Pythag. Okay, so we know this already. And we're looking for the distance of AB. So, well, AB squared is equal to AM squared minus radius squared, which is 5 squared. Okay, BM was the radius of the circle. So now we just need this AM. So AB squared, we need the distance of AM squared. So the square root, distance from A to M, all squared, minus 5 squared, which is 25. So if we look at the distance from A to M, A is TT. So both our X's and our Y's are going to start with T. And our m can minus t minus 3 is for x minus x, and t minus minus 5, which is plus 5. Okay. Quickly clean this up a little bit. So the square root squared cancels out. And then if you have t minus 3 squared, it's t squared minus 3t times 2 for the two middle terms, the inner and outer. So minus 6t. And then minus 3 times minus 3 is plus 9. So that's just to expand the square bracket. Same thing, t squared plus 5 times t times 2 is 10t plus 25 minus 25. We're starting to get somewhere. This looking pretty good. First thing I notice, 25s cancel out. We look at like terms. We have minus 6t plus 10t minus 6t plus 10t minus 6t plus 10t gives us 4t. Where were we? Plus 2t squared. We really should have done the t squared term first. Plus 9. Let's just rearrange that into order. You always want your squared term first. We're looking pretty close to our required answer. Pretty close. We still have ab squared. So now we take square root of both sides. And if you take square root of both sides, we get our answer. Always just check that it's the correct thing. That concludes question 4.4.1. 4.4.2, determine the minimum length of AB. So here we have our AB. We know that for min-max, our first derivative is equal to 0. So that means that dy dx is equal to 0, but we're not working with y, we're working with AB, so dAB over dt is what we're trying to get. But with these sorts of questions, I don't want to be working with a square root. First derivative of a square root, that's not fun at all. So the first thing we can do is just square both sides again. We're going to be looking for the first derivative of AB squared. And at the end, we can get it back to AB quite easily. So first derivative of 2t2, you take the 2 times the 2, and then you minus 1 from the original 2. Okay, so we want to find the first derivative of AB. So it'll be 4t, and then we want same thing here. So this is t to the power of 1, so 1 times 4. 1 times 4 is 4, plus 4. And t, 1 minus 1 is 0. So there's t to the power of 0 is just 1. So it's 4t plus 4. And we know that for min-max, the first derivative is equal to 0. We want that equal to 0, and we're asking what t values are we going to end up there. So, well, if you minus 4 from both sides, you'll get 4t equal to minus 4. Divide by 4 on both sides to isolate t, get t on its own. Those cancel out. T is equal to -1. So we know that the t value is going to be -1. Okay, well, next step in min-max is you take, when you're trying to find the minimum or maximum value of a curve, well, so far we'd have the x values. This t minus 1 is, this curve only has one x value, so it would be, this would be, this one's concave down. This one's concave down because it's this frowny face, and this one has a, therefore it has a maximum value. So that's, they've asked for the minimum value, so we actually want the concave up. This one's concave up, and that one concave up has a min value. So we know that this is actually the x, it's the x of the min value. And the way we figure out what our actual min value is, we sub this x value, we sub it into our original formula that we made to find the minimum distance, or the minimum length, sorry, in this case, of AB. Right, so we have our AB squared. AB squared was equal to, did AB squared, yes, that's correct. AB squared is equal to, without the square root, 2t squared plus 4t plus 9. We sub in x, oh, excuse me, not x. We sub in t equal to -1, and we get that AB squared is 2 times -1 squared plus 4 times -1 plus 9. This is to work out the minimum distance that AB can be. So AB squared, -1 times -1 is just 1. So 2 times 1 is 2. 4 times -1 is -4, plus 9 is just bring it down. So it would be 11 minus 4. And 11 minus 4 is 7. But we're not finished because we, for convenience sake, working with first derivatives, we used AB squared. So now we just take the square root of both sides. So the minimum distance of AB is going to be square root 7. This is the correct answer. We'll just come back to this min value. Because there was only one t value, we can assume that it's the min. It's definitely the min. If there had been 2 t values, then we have to do the second derivative test, which we won't talk about in this video, but just to remember that if there's more than one t value, you can't assume that it's minimum. It might be max. It might be max. So either the second derivative test, or you can do it by inspection, looking at these smiley frowny faces, and we can determine if the y is higher up. If our y is higher up, that's going to be the maximum value. And if the y is lower, just logically speaking, this will be the minimum value. This is the graphically represented, the calculus behind this, calculus theory. Right, and that's the end of question 4.4.2. And I think that brings us to the end of question 4.